Hi friends, today I am gonna show you how to prove equations of motion. I'll prove three equations of motion by two methods, the representative method and alternative method. So let's see how I'll prove it. Here these are the three equations of motion as we know. V equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2s. So now let us see how I will prove it by graphical representation method. So let's see how to prove it. Here I have a graph ready. Here you can see that initial velocity or u equal to OA at time equal to 0 seconds and final velocity equal to OC at time t seconds. I have used these two things from the graph given alongside. Now we gonna prove the first equation. So A equal to slope of the line AB. Slope of the line AB. So EB by AE, or AB equal to AC and AE equal to BC equal to AC by OD, which means AC equals to OC minus OA by OD. Here OD is the time taken by the body and OC is equal to V and OA equal to U. So we can write V minus U by T. So let us write it here. Now we have got A equal to V minus U by T, or AT equal to V minus U, or V equals to U plus AT. So friends, this is the first equation of motion. Now let us prove the second equation. We know that the distance traveled equal to area of the trapezium OABD, which means the sum of the triangle ABD and rectangle OAED. So now let us prove that. For triangle ABE and rectangle OAED, we can write OA into OD plus half into BE into AE, or equal to U into T plus half into V minus U into T, equals to U into T into half into AT into T. We have got V minus U equal to AT from the first equation, which means UT equal to half AT square. And this is the second equation. Actually it's S equal to UT plus half AT square. Now we will prove the third equation. We also know that the distance covered is equal to area of the trapezium OABD, which means that area of trapezium OABD equal to half into sum of parallel sides into OD. So let us write it here, half into OA plus BD into OD, which means S equal to half into U plus P into T. S equal to half into U plus P into T. But from equation 1, we have got T equal to V minus U by A. I have shown it alongside here. So AT equal to V minus U and T equal to V. So we have got from here T equal to V minus U by A. So let us put it here. So now we have S equal to half into U plus V into V minus U by A, which means S equal to half into V square minus U square by A, or 2AS equal to V square minus U square, which means V square equal to U square plus 2AS, which is the third equation of motion. So I have proved these three by the graphical representation method. Now I am gonna prove it by alternative method. So let's see how I'll prove it by alternative method. So you can see here that we have proved all the three methods. You can zoom in and see it here. Now we will move towards the alternative method. You can zoom it. Now alternative method. For equation 1, by definition we know that acceleration equal to change in velocity by time taken. So let us write it here. which means acceleration equal to final velocity minus initial velocity by time taken, or a equal to v minus u by t, or at equal to v minus u, or v equal to u plus at. So this is the first equation. Now for second equation, by definition we know distance traveled equal to average velocity into time, or distance traveled equal to initial velocity plus final velocity by 2 into time taken. So s equal to u plus v by 2 into t, or from equation 1 we got v equal to u plus at, so s equal to u plus, so putting that value from equation 1, we can write it here as s equal to u plus u plus whole into u plus at by 2 into t, or s equal to 2u plus at by 2 into t, or s equal to ut plus half at square. And friends, this is the second equation of motion. Now for third equation, we know distance traveled equal to average velocity into time taken. So let us write it here. Now we also know that s equal to u plus v by 2 into t. But from equation 1 we have got v equal to u plus at, or t equal to v minus u by a. This is the same thing as I have done for the graphical representation method. So let us put that value here. S equal to u plus v by 2 into v minus u by a, or s equal to v square minus u square by 2a, or v square minus u square equal to 2as, or v square equal to u square plus 2s. This is the third equation. So I have done all three by alternative method.